That's what we are looking at today. Progression, which is known as the GP. GP for geometric progression. This one, you multiply a constant number for you to get the next number. Is that okay? So you multiply the constant amount. Let's see. You have a constant amount that you're multiplying by the previous number for you to get the number that follows. Isn't it? Yes. So that one is known as the common ratio. So for a GP, we have what we call the first term. For a GP, we have first term.
The second term.
First term is denoted by A, and then we also have a common ratio. Yes, common ratio is denoted by R, isn't it? Common ratio. Now, if you want to find the common ratio, let's say you want to find the common ratio. So you say common ratio is equals to T2 over T1, which is equal to T3 over T2, which is equal to T4 over, and so on and so forth. Or we can say Tn over Tn minus 1. Are we on the same page?
Yes.
I can see Madam Gloria, you want to ask a question? Everything is okay?
Yes.
Okay. Yes? You want to ask? Yeah. You want to test the microphone? Yeah? Okay, so here we have T2 over T1 is equal to T3 over T2, and then we have T4 over T3, which is equal to T8 over Tn minus 1. Is that okay? So if you are finding the nth term of a GP, Tn is equal to AR to the power n minus 1, where n is a natural number, meaning that these are numbers that are used for counting. Like you have 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Is that okay?
Yes.
Now, let's go to that question now, question 4, where they are saying that the three numbers, x minus 1. Let's go on that example. There's an example that has been given to us. So we are saying we have been given three numbers, isn't it? The three numbers, x minus 1, x, and x plus 3 are consecutive terms. They say consecutive terms in a GP. Yes, meaning that they are following each other, isn't it? So we have, like you can say, this one is T1, T2, and then we have T3. Are we together?
Yes, sir.
So they are asking you to find the value of x. Find the value of x. Now, common ratio is T2 over T1, which is equal to T over, and this one is constant. So if you look at this one, we'll say T2 is x over, what is T1? X minus 1 is equal to T3 is
X plus 3.
what is T2?
X.
And then we're going to cross multiply. Is that okay? So we'll say x times x,
X squared.
which is equal to x minus 1 times x plus 3. Is that okay? Now here we have x squared is equal to x times x plus 3 minus 1 times x plus 3. I'm sure you remember these things. These ones we were doing them under algebra. Now here we say x squared is equal to x times x,
X squared.
x squared, plus x times 3, it's 3x. Negative times x is negative x. Negative times this one, you get negative 3. Are we on the same page?
Yes.
Now here we have x squared is equal to x squared, and then plus 3x minus x, 2x minus 3. Are we on the same page?
Yes.
Now x squared is equal to x squared plus 2x minus 3. If I take this one this side, it means our x squared minus x squared is equal to 2x minus 3. Isn't it? Now this one and this one, x squared minus x squared is 0. So I'll say 0 is equal to 2x minus 3. Are we on the same page?
Yes.
So I can start with this one. I can say 2x minus 3 is equal to 0, isn't it? Implying that 2x is equal to, I take this one to the other side of 3, divide this one by 2, divide this one by 2. This one and this one, this x is equal to 3 over 2. Okay, then that's the value of x. I've solved for the first one. Do you have questions? Yes, anyone with questions? Questions? Yes, do you have a question? You're the one who's supposed to ask a lot of questions. The reason, you know the reason.
So like those the first term and can. So are those the formulas you have to use?
No. For now, we want to find the value of x. And then, like, if you look at do you have the questions? If you have the questions there, they'll ask you, like the next question, say, the common ratio. What is the common ratio? So number one, we need to know the value of x. Once we get the value of x, then we can answer the questions that follow. So like the next question is find the common ratio. Now the common ratio is where there's x, we put 3 over 2. Isn't it? So like now we can substitute because we know what t1 is. Since we know what x is 3 over 2, then t1, look at t1. T1 is x minus 3. But what is x? X is 3 over 2 minus 1, which gives us half. It's giving us 1 over 2. So T1 is 1 over 2, is half. Then what is T2? T2 is what? T2 is x. It's 3 over 2. Are we on the same page? Then we can use this one to find the common ratio. How? Ask me. How, Mr. Kazo?
Oh, Mr. Kazo.
Very simple. A very good question. You have asked me a very good question. This is how you do it. So you say common ratio is equals to T2 over T1. But what is our T2? Our T2 is 3 over 2. Over, what is our T1? Our T1 is 1 over 2. Is that okay?
Yes, sir.
Now, here you say, this is the same as saying 3 over 2. Divide this one by 1 over 2. Implying that we have 3 over 2 times, because we are changing the operation. There is division there. Isn't it?
Mm-hmm.
So when I put multiplication, it means I'm also changing this 1 over 2. I'm going to write the reciprocal of 1 over 2. What is the reciprocal of 1 over 2?
2 over 1.
Very good. Okay. So now 2 into 2, it's 1. 2 into 2, it's 1. We have 3 times 1
3.
over 1 times 1, it's 1. 1 into 3.
3.
Yes. So meaning that our common ratio is 3. Okay, so we can say common ratio is 3. Is that okay? Madam, are you following?
Yes.
Okay, good. Any doubts?
Means the question was that one, which is r is equals to 2. I don't know if it's 2. Is it term 2? I don't know if it's first 2. T2 over T1. Those are formulas we should use, Steph.
Can we call that one as a formula? It's okay. Yes, that's what we are supposed to use, because we have we say the second term over the first term. All right, this is a sequence. These are numbers that are arranged in a definite pattern. You will know that after 2, example 4. After 4, we are 8. After 8, we are 16. After 16, we are 32. Man, if no pesa, why is in a system 1 Java 1 2? So say, oh, they are multiplying by 2. So and that 2 is called the common ratio, because it's the same it's a same ratio throughout. What is a ratio? A ratio is a comparison, isn't it? What are you comparing? So as we are comparing T2 over T1. In other words, we are saying that number x ogolo over number ikumbulu. So number x ogolo ikani T2. Number ikumbulu ncha T1. That's what we are doing. And then what we get is called a common ratio. And then it's the same throughout. Mambeka? Okay, good. Now let's move on to the next question there, where they're saying that, can you find the third term? The third term. Now, third term, that's the question, huh? You see that? Find the third term. Okay, so the third term, T3. Now T3, remember we said Tn is equal to AR to the power n minus 1, isn't it?
Yes.
But now as we are finding T3, T3 is equal to AR to the power 3 minus 1, implying that we have a T3, or we can say A. What is our A? Our A is half. Huh?
Yes.
1 over 2 times, what is our R? Our R is
3.
to the power,
3.
yes, which is 2, isn't it? Yeah? Now we're using BODMAS. So BODMAS, it requires what the powers, those are the ones that you start with. Because these ones I've put them both in brackets, but the one with the power, that's the one you start with. Okay? So here you have 1 over 2 times 3 times 3. 9. So we have 9 over 2. This is T3. You can't? What is it? Leave it like this. Okay? I know what you are saying. What you are saying is say 4. 4 and a half. Or 4.5. Yes, leave it like this. Is that okay? Yes. Because we are looking at track. Because common ratio is the first term is 1 over 2. So even this term, third term, put it like that. As it 9 over. Okay? Yes. Questions? Now, I'm going to geometric mean. I'm going to ask you the question that I asked yesterday. So yesterday I asked about if you see the word mean, mean is in statistics they say this one is the measure of central tendency. Okay, where we have the mean, the mode, and the median. These ones are used to measure the central tendency. What does it mean? What it means is that if you want to know vidi pakati. Alright. For example, you have 3 numbers. 1, 2. Number kwa vidi pakati?
2.
Yes, it's 2. So that 2 is the mean. But how do I calculate the mean? Okay. Are you going to ask me a question?
How are you going to calculate the mean?
Very good question. You are smart, you are. Okay. So this is how we calculate the mean. Mean is you add the items, the numbers, which is 1 plus 2 plus 3, over the number of items. How many items do we have? 3. So we say 1 plus 2 plus 3
6.
over 3. 3 into 6, what do you get?
2.
That's a mean. And this one is the arithmetic mean. Arithmetic mean. This one, the one I've just calculated. Now, we are looking at geometric mean. So, geometric mean, we are using the concept of common ratio. Suppose you are given, this one is GM, right? Suppose you are given A, B, and C. The geometric mean is B. Okay. Are we on the same page? But the concept that we are using is the one for common ratio. Now, how do you find common ratio? You say this one is T1, T2, T3. Now, we'll say common ratio is T2 over T1, which is equal to T3 over T2. Very good. So here what we have is B over A, which is equal to C over B. Now, B times B.
B squared.
Yes, so I'll say B squared. This is equal to A times C.
AC.
AC. Now, for me to find B, I'll say B is equal to plus or minus square root AC. Is that okay? This is the geometric mean. So the formula for geometric mean is B is equal to plus or minus square root AC. Okay, so geometric mean is given as plus or minus square root of AC. Madam Fine, are we on the same page? Okay, we'll give you the mic. So that you don't think. So don't like, I'm the one with the mic, you know. No, this one's not making noise. Okay. So let's look at an example. There's an example there. So the example is, find two possible values for the geometric mean of 5 and 20. Geometric mean of 5 and 20. Now, remember what we said. We said geometric mean is given by plus or minus, and then we have A, C. What is our A? Our A is 5. What is our C? Our C is 20, isn't it? So we said GM, geometric mean, in this case will be, we have plus or minus, and then there is 5 times 20, which gives us plus or minus. What is 5 times 20? It's 100, isn't it? Now, what is the square root of 100? 10. Yes. So this one, we have plus or minus 10. So the geometric mean, we have 10 and negative 10. Two values. Are we on the same page? Find two possible values for the geometric mean of 16 and 36. I've skipped B. I've gone to C. There we're saying C. Have you seen that one?
Yes.
What is 16 times 36? What do you get? 4. 4 times 6.
507.
Do you know what's the square root of 500? The square root of, yes, your answer
20.
is 24. So plus or minus 24.
That's the answer.
Yes, for the last one there, 16 and 36. But now my interest is, let's look at this one there. Where we want to find the GM. GM of negative 4 and negative 4. Isn't it? Huh? Yes. So this one will say GM is equal to plus or minus, okay, negative 4 times negative 1 over 4 times negative 4. So what you are getting is plus or minus, okay, square root there. You have, what are you getting? Negative times negative is positive. So we have 4 over 4. 4 into 4?
1.
Yes. So here you get 1. So meaning that we have 1 and?
Negative 1.
Yes, and negative 1. Very good. Yes, you can talk in this one. If you have questions, please ask. Don't be like that guy called Safuns. This guy never used to ask questions. Yes. No, the C is, remember from the formula that I was giving you. Here. Remember, yes. So that's where we're getting them. Yes. They are just notations, just for, you know, just. Yes, so it's a concept there. So, oh, suppose we're given a situation like this. So I use letters there so that you understand. But now suppose you have numbers. Because of the square, B squared.
Yes.
Yes. Ah, okay, good. Yes. Mrs. Kunda, is everything okay? Ah, they're not asking questions. Ask questions, but not like for this one. When it comes to the sum of a geometrical progression, the formulae will be given to you. Yes.
What's the difference between the formula?
The formulae, there are many. The formula is 1.
Yes. So one is singular, one is plural. Is that okay? Yes. She doesn't want to be like that guy called Safums. Whether she's asking questions. Okay. So the sum of a geometric progression So the sum of geometric progression is the sum of a geometric series is the sum of a geometric progression. So we can have like the one that we have, let's say, where we have, maybe this one, for the first term is 1/2 there, and then those we have a GP there. When we add them, when we add them, that's a sum. If they say that, can you add the first 10 terms? So the answer that you get here, that's a sum. Okay? Sum means addition. Sum means the answer that you get after adding. Okay? Can I erase this? Okay, so sum of a geometric progression. If you get a past paper there, you'll find that we are looking at the sum of a GP Sn. Okay? Where's Beatrice? Sum of a geometric progression. We say sum of geometric progression, we have A there, and then R to the power n minus 1 over R minus 1. When what? When R is greater than 1. Is that okay? So there is a condition there. The sum, we can, if you want us to come up where it's coming from, we can do that, but take a bit of time. So you can just know it, because the formula, again, the formula will be given to you. There, that I gave you an example of someone.
Yes.
Yes. So it's there. So Sn, that is the sum of the GP. Is A is the first term, and then open brackets we have R to the power n. That is a common ratio to the power n, isn't it? Minus 1 over R minus 1 there. Okay. Suppose R is less than 1. Then this one changes also. It means that Sn is A, and then we have 1 minus R to the power n, isn't it?
Yes.
Over 1 minus R here. Is that okay? So there's the condition that is for this one. When R is less than 1. Okay? Yes. Now, we also have what we call the sum to infinity. Sum to infinity is A over 1 minus R. When absolute value of R is less than 1. Absolute means positive. Take it positive. Even if R is negative, we will take it as positive. Is that okay? Yes. Okay. Now, let's look at an example. They're saying example 2 there. Find the sum of the GP. That is the sum S10 there. The sum of the first 10 terms of a GP, given that the GP is 1 over 2, 1 over 3, 2 over 9 there. To 3 significant figures. Are we there? Have you seen the question? Huh? Yes, example 2 there. On example 2 there. Example 2a, they are saying S10 of a GP, given that we have 1 over 2, and then 1 over 3, and then 2 over 9, and so on and so forth. I thought we have 1 over 9, now we have 2 over 9. Let's get the common ratio. I've seen the first term here is 1 over 2. Now, what is the common ratio? Common ratio is we say 1 over 3. Divide this one by 1 over 2. Meaning that we have 1 over 3. Divide this one by 1 over 2. 1 over 3 times 2 over 1. So we have 2 over 3. Do you agree with me?
Yes.
You have repeated the T2 divided by T1 again as T2 divided by T1.
I've repeated this one. Which one?
The second one.
This is T1. This is T2. Right? So I'm saying T2 is 1 over 3, isn't it? Over 1 over 2. Meaning that this is 1 over 3. Divide this one by 1 over 2. Isn't it? Now, here we have 1 over 3 times 2 over 1. 1 times 2, what do you get? 2 over 3 times 1. What do you get is 3 times 1, madam, what are you saying? It's 3. So we have 2 over 3. Yes, now what are you saying now? I've repeated what?
I was confused. greater than T2 divided by T1.
Okay, now we have the common ratio. The common ratio is 2 over 3, isn't it?
Yes.
And then we have n. N is 10. Now, my interest is look at the value of r. Is it greater than 1 or is less than 1? Yes, it's less than 1. You've seen it? It's less than 1. Madam, have you seen it? 2 over 3. Niti cool. Pari 1 na 2 over 3. 1 equals 1. So common ratio at if 2 over 3. Means that ningon pari 1. So it's housing height.
The one on.
Alright, less than 1, isn't it? So we say S10 is equal to A. What is our A?
1 over 2.
And then what is our? We have 1 minus our R is 2 over 3 to the power 10 over 1 minus 2 over 3, isn't it? Are we on the same page? Now 1 over 2, and then this one is 1 minus 2 over 3 to the power 10 over, what do you get there? 1 over 3. Is it? The power 10. So, thank you. The power 10. What do we get? 1 minus 2 over 3. What we get is?
-5.
No. Yes? What's the answer? 0.3. No, I want the answer just as a fraction.
Yeah.
Yes, as a fraction. It's very simple, madam. It's very simple. Each time if you are subtracting from 1, you say, have you seen this number? Subtract, you say 3 minus 2. What do you get? You use 1 over 3. The denominator is the same. So it's 1 over 3. Is that okay? Yes, I learned this when I was in grade 5 at Mchinga. There Mchinga. Okay, I learned about this. And I'm still using it now. Now, this is what you do. We have 1 minus 2 over 3 over 1. So this is 3. 1 into 3 is so?
3.
3 times 1?
3.
Minus. 3 into 3?
1.
1 times 2?
2.
3 minus 2?
That's 1.
Over?
3.
Yes, that's the answer there. Is that okay?
Yes.
Now, here we say S10 is equal to, this one is 1 over 2, and then we have 1. Someone to find this one, 2 over 3 to the power 10. What are you getting? Put it in brackets. What's the answer?
6.6.
Get the calculator, you people, 2 over 3. And then the rest to the power 10. What are you getting? 6 point. 6 points. Times 10 to the power what? Obviously something. Madam, let me help you. So get your calculator. Alright. So this is your calculator. So what we are finding is this is the calculator, scientific calculator, isn't it? So it's cast. So this is what we are doing. Put brackets here. Open brackets, and then you have 2 over 3 there. 3. Close. And then power. This is the power. The power 10. It's giving me 0.017. I don't know the calculator there.
Yes.
Buy a calculator in book world. Don't buy a calculator from.
It's 0.017.
So we have 1 minus 0.017, isn't it? Are we on the same page?
Yes.
Yes, now 1 minus 0.017, it's almost 1. Because the answer there, this is almost 0. If you round it off, it's give you 0, isn't it? So you have 1 there. So you have 1 over 2 and then 1. Are we on the same page? Now remember that we are also dividing this one by 1 over 3. So here we have 1 over 2 and then over 1 over 3. Meaning that we have 1 over 2 divide this one by 1 over 3. Implying that we have 1 over 2 times 3 over 1, which is 3 over 2. Are we on the same page? Please, where you don't understand, ask. Don't be like some guy called Safunsa. This guy never used to ask questions. So what he did, he got the wax from the ears. He started eating, you know. He thought it was honey. Ouch. Safunsa anadia pool. Say people from the east. Safunsa anadia pool. Yes, this guy never used to ask questions. So don't be like that guy called. That one is grade 12 mathematics, paper 2, internal. So we have gone to examination questions now. On GP, mathematics, paper 2. Examination questions. So let's see if we can answer 3 questions so that we have confidence. So the first question is internal. That is grade 12. Paper 2, internal, 2024. Internal, in fact. It's not internal, 2024. It's just for last time. So we are saying, given the geometric progression as 10, 30, 90. Find the 10th term. That's A. B. Sum of the first 6 terms. And then C is find the geometric mean. GM, geometric mean of 2,430 and 1,870. Are we on the same page? So from your question, this one is an examination question. If you get a past paper, you find this one. Okay? So they're saying that given that the GP is 10, 30, and 90, find the 10th term. Find the 10th term. Now, can I attack or I wait for you? You have the, you just write solution because you have the papers, isn't it? You have the papers. These papers you have. So you are just writing the solution on question 1, examination question. So just put in, and then you're waiting for the solution. Okay, so we say, let me attack. Do I have the tools? What do I need? Beatrice, what do I need? To answer the question. Yes, do I have common ratio? Help me to find the common ratio. So I need the common ratio. Common ratio is T2 over T1. Now T2 is 30, isn't it? Here. And then T1 is 10. So we have 3. The common ratio is 3. Do you agree with me? Okay, and then what else do I need? The first term is 10. Now I have n. What is my n?
10.
Yes.
10.
10, isn't it? 10th term. Okay. Now they are saying I should find the 10th term. So I say Tn is equal to AR to the power n minus 1, isn't it? So I'm finding T10. T10 is equal to 10. What is R? 3 to the power 10 minus 1. So you have 10 and then you have 3 to the power 9. Okay. If you want, you can say, you can find that one using 3 to the power 9. What are you getting? Yes. 3 to the power 9 times 10. That's the answer. I'm going to be the sum What is 3 to the power 9? Times 10.
Oh, 9 to the power.
3 to the power 9. It's 19,683 times 10. You have 196,830. So that's the answer. But leave it in that fashion. The sum of the first 6 stages. Madam, are you following? What, you are lost?
No, B and
B. Okay, yeah, I'm going to solve B. I'm waiting for you to just to finish. I'm going to solve B. So I'm going to solve B. I'm going to solve B. So B, they are saying sum of the first 6 terms. It's very simple because we know our first term. What is our first term? Yes, and then what is our R? Is it less than 1 or is greater than 1?
Greater than 1.
So we know the formula to use, isn't it?
Yes.
When R is greater than 1. Okay. So we'll say Sn is equal to A, and then we have R to the power n minus 1 over R minus 1. Now here we have S6 is equal to A is 10. Okay, and then what is our R? Our R is to the power 6 minus 1. Here, minus 1 here down. Over, this is 3 minus 1. Now here we get 10 there. And then we have 3 to the power 6. What do we get? Those with calculators. 3 to the power 6 minus 1. 3 to the power 6. Let me wait.
729.
Minus 1. Okay. So here you are saying we are getting 729
28.
minus 1. Over 3 minus 1 is 2, isn't it?
Yeah.
So here we have 10 there. And then 729 minus 1 is 728 over 2. Matumu 10 yang again is 5. 5 times 728. What are we getting? Yes?
3,000.
What are we getting? 5 times 728.
26.
What?
3.6.
You cannot have a point. Yes?
3,640.
3,640.
40.
This is the sum of the first 6 terms. What? Yes, it's a comma. Yes. So I knew that you're talking about comma. Yes. So it's 3,640. I look at them in terms of numbers, like people, like 3,640 votes. If there's one thing that is difficult is to win elections. Those people, it's people, baby. Those is the struggle, like Sata. He was very strong. May he so rest in peace. 3,640. Okay, now the last one, GM of that is the geometric mean of 2,430 and 21,870. How do we find that one? You give us the formula. Oh, you want to come and solve in front?
No, sir.
Okay. This is, do you want to come and solve? Okay. So my name is Mr. Kazov. I'm going to write it on the book.
Oh, no, Mr. Kazo.
Okay. GM, can you try GM? The geometric mean, the last one. The last one is very simple. So, geometric mean, you remember what we said, right?
Yes.
It says plus or minus, huh?
As I
And
give
then
you the
we
formula.
multiply this one, yes. 2,430 times 21,870. Okay? What are you getting? So here you multiply this one and then find the square root there. That's your answer. But what did you find?
7,000.
Yes. So here we are. Plus or minus 7,290. So we can have 7,290 or negative or and. So you can use the word and there. And 7,290 and negative. Can I use and? No problem. I.
Yes, you may.
But I mean the same thing. And O.